You don't know what you're gonna get. you, you don't know what you're gonna get. Okay, so we finished everything except the mechanical panel. Very short now. It's done, guys. A few things. I did give you guys a copy of DeWalt. Can you guys grab that copy that I gave you? Let me just walk you quick through it, please. That little copy that you have. Can you guys see at the bottom is 3.12, 3-12, and the next page 3-13. So when you see a DeWalt 3-12 or 3-13, they're referring to these two pages. Can you guys see how they look like? These two pages. Cool. All right, look at the top. The first page, 3.12. Sizes of panel boards. Can you guys see the sizes? Standard industry size of panel boards. That's what I was getting this info. Right underneath there, the first one is single phase. Don't look at the single phase now. The second one is what? Three phase. Right underneath it is sizes of gutters and wireways. That's also important. We're not doing it now, but later on. Right underneath it is the sizes of disconnects. Later on, guys, in industrial, you're going to be sizing disconnect. These are the industry standard disconnect. Can you guys see that? So when you want to disconnect. Right underneath it is sizes of pole boxes. When you become an engineer, you need size standard industry pole boxes are here. Now flip to the second page here. The second page, guys, give you busway or bus duct size. Can you guys see that?
Yep.
The single phase and three phase from 225 all the way to 5,000, right?
Yep.
Then right next to it, circuit breaker and fuses. The circuit breaker and fuses branded sizes are from the NEC code book, 240.6. So you either go here or the 240.6. So these are from the code. The last one, guys, have switchboard or switch gear. Now, when you guys are looking at the panels, look at the three-phase panels, it stops at 600 amp. Can you guys see that? 600 amp. Now, what happens if you need more than 600 amp? You go, no, these are panel sizes. Panel sizes. The panel size, if you guys can switchboard and switchboard and switch gear, it starts at 400 amp all the way to 4,000 amp. These are different type of panels, big, fat, fluffy panels, basically. Single phase and three phase. In between them, there's the one that handwritten are generator sizes. Can you guys see that? Gen sizes. I just wrote them by hand. And the one way at the end, the written, handwritten on the right side, can you guys see that? That's a UPS sizes. I picked these UPS sizes when we size in the spring. These numbers you will be using. For the time being, all what you need from this page is really the overcurrent protection device, the fuse or circuit breaker, and the panel size or the switch gear size. Okay? All right. Now you have the magic things. Okay, let's go to the mechanical panel, gentlemen. Mechanical panel. My mechanical panel, the last panel we're going to size, you guys agree that it was 159 K, no, not KCM, KVA. Thank you. Divide this by 1.73 because 3 phase, 208. It will get you a healthy 400, it looks like, and 42 amps. Now, you take this one to 442. Do me a favor, guys. Go to DeWalt 3-12. DeWalt 3-12, do you see a panel size? What's the next standard panel size? 600. See where the 600 seems to be here? Thank you. 600 amp. What happens if you run out of 600 in the panels? Where do you go? You got it. You guys are so fast. You got it. Got it. That's it. Okay, 600 amps. So 445. Now, the overcurrent protection device, I have 442 amps. Now, this is 240.6, which is also in the sheet that I gave you, by the way. And the next standard is what? Thank you, 450 amp. Can you guys see that panel size is bigger than the circuit breaker? Yeah, because you don't make panel sizes for every circuit breaker. Okay, now it's up to you, Jay. Would you up this 450 to 600? That's a big jump, right? 150 amp. 150 amp, guys, money and wire and conduit. So most likely I will stay at 450. So I'll buy the 600 because that's what I have. And I'll stay. Actually, some engineers, they might drop from 442 into 400. But don't do that. That's a different story. But standard, the way you do it is you go to this and then to this, and what you come up, you're stuck with it, basically. Yes, sir.
Can you go to 500 because a little bit of
You can. Now, when we size, you ask yourself as a designer, have I anticipated future loads? I want to remind you, I mean, if you already anticipated the future load and into this 442 amps, why should you go? If you have not, maybe it's a good idea to go to 500. You know what I mean? See what I mean? There's a leeway and judgment. That's why Michaud has all these standards, guys, for you. Use this, use that. Other than that, that's what the calculation come up with. Okay. Overclock protection device. Now let's go down to the feeder. The next step, guys, we're going to go size our feeder. So our feeder, remember, match the overclock protection device, and it was 450, not the panel. So you take the 450. Now, what's the problem with 450J? Do we have the feeder that can carry 450 amps? Look at the 310 of 15B16. 310 of 15B16. I told you Twin Cities. Now, if you're from Iowa, you don't know the Twin Cities, you're still in trouble too.
I know them well.
A little bit. It's Richfield and Bloomington, right?
Yep. That's it.
So they don't have more than. Do we have 450? They don't have 450. So what do you do? No, we're gonna find a cable for it. Yes. What's the word? Parallel. I hate that word. Divide by 2.
Okay.
So when you divide by 2, gentlemen, you get yourself 225 amps. Now you take the 225 amps to 310 of 15P16, 75, and gentlemen, when you go there, you're going to get 2 sets. Each set is going to have 3 conductors, and each conductor is going to be 4 aught, right? A, W, G, T, H, H, N.
We said we don't want to go above 600, right?
Yes, 600 kcm, which gives you close to 400 amp, right? That's kind of where you cut off. Yeah, there is an amp to carry the 450, but you don't want to go higher than. Good point. You don't want to go, guys, higher than 500 kcm or 600 kcm. 600 kcm is you cut off for sizes. Why? Yes, because then it becomes too big to install for them, too hard. It would be more economical to actually pedal them.
Is it cheaper?
Yes, when you take everything into consideration, it would be, I would say it would be cheaper. A little bit, not a lot though. Parallel them instead of running one, when you take the labor involved in it, especially in conduits.
We had 3 big spools or whatever on the back of the trailer, and it was $16,000 for 500 wire. 3 of them big spools,
Yep.
you know,
To pull the wires,
How many was the wire?
500 wire.
500 kcm. Yeah.
It's
The-
like something that-
Yeah. The problem with the
Yep.
wire, guys, is not just one. You're looking at 4 of them.
3 with
4 this size becomes a big chunk. Now the bigger, imagine 4 this size. How are you gonna? You might not even find a conduit
We had 5
You don't-
guys
you
at
wouldn't
every
find it.
corner of the raceways.
pulling it.
Well,
And
just
it
for
just
the corners.
yeah,
To feed it in there.
yeah.
Does the weight have something to do with that too?
Yeah, it's heavy.
Well, and if you're doing it in the ground, you wouldn't. Oh, this one is not going to be in the ground. Yeah, weight lifting it, attaching it, another. Huh? Okay, thank you. Now let's look at this, guys. Feed the feeder neutral. What was the KVA for the neutral in this panel? Big fat floppy 0K VA divide by 1.73 times 208. That will give you a big fat floppy 0 amp. Right? 0 amp. What does that mean? This panel has nothing connected to the neutral. Nothing. Nothing. It's nothing connected to neutral. Now, your job now, you guys as an engineer, you have to decide. You can stop here and say, well, I'm just pulling 3 conductors to this panel, no neutral. You can. Or you can pull neutral. I don't like not to pull a neutral to a panel, because you put the panel there, maybe in the future you'll pull something to the neutral. So if you said 0 and just 3 conductors, you're right. You're right. Another way that I personally assume is you can assume, remember the amp, the whole, now remember, this is the right answer too. Now, if you want to be, you know, have a neutral, just have a neutral there in the panel so you can use it for the future. Here's the assumption. Assume that the I neutral equal the I the phase. Remember the phase? What was the I for the phase that we just came up with? The I the phase. 442. 442. Could you please write next to this? This is big wild assumption. You know, just to pull a neutral. You know, I want to size it exactly like this is no way on earth it could reach that value. Okay? And then remember what happened if the neutral is more than 200? What do you do? And that's what you're sizing.
So I on the bottom, and then you got like a chicken foot.
This one here?
Not the other one.
Neutral.
This is neutral.
Is that the symbol for neutral?
I. That's my neutral.
The one next to it.
Phase. I neutral. Oh man, this is my I n equal I phase, the zero. Sorry guys, it's out of commission.
Does it just need to be recalibrated?
Recalibrated.
I'll do it for extra credit.
I'll probably just put a spot. Yeah, look at that. There it goes.
Is recalibrated. And even still with the recalibration, guys,
It's still weird.
it's not that whole, it's not like you're writing on a board. So I neutral. Better.
Nice.
Oh, and 50% of the problem is the writer, if not 70. The rest is the board. Maybe 80. Then the board will contribute with 20.
So we don't need a full neutral.
You'll be fooled to do full neutral in a mechanical panel like this. I mean, look at the loads; they're all three phase. Okay, these are the assumptions that you guys do, the engineers will do. Typically, you know, you pull a neutral but not full neutral. Okay, so let's go apply the demand on that guy, guys. So yeah, I'm gonna go take this value. The first 200, what do you do with them? Don't touch. 4, 4, 2 minus 200. Cut this by what? 0.7. Add them up. And gentlemen, you're going to end up, when you do this math, you're going to end up with 370. 370 amps. Now remember, if you put no neutral, you would have been right too, because there's nothing on the neutral. Okay, everybody knows that whole 200 and blah blah. We've done it a trillion times now. Okay. So that's the neutral I'm going to use. Now let's go find a conductor to carry it. First you find, can you guys see when we size conductor, first you find the amps, and then you're going to go find actual wire to carry. Actual wire. Let me know when you're good.
Oh, before you walked in, you had a missed call too. Like a Skype. Yeah.
Skype call?
Someone tried calling.
Does it say Evan? Hella,
Yeah,
Evan?
yeah.
Oh my God, my sister here. I should have answered it and turn it and give her the,
Is that the same one you did it to before?
yeah. She's in
She
England.
hasn't learned, yeah.
Well, what time is it? They're 6 hours ahead of us.
Oh,
So,
yeah.
but she should know better though. Should be here. Okay, now, do you guys remember that 270? I have 270 amps. Now, I can go
Yeah, 370.
370. I'm just off by 100.
That's no big deal.
Not a big deal. Not a big deal with my friends, is it now? 370. 370 amps. Okay, now I can go and find one conductor to carry the 370, no problem. And you can tell me what's the but? What's the issue with but? Why can't I do one conductor? You already put two sets. If you parallel the phases, you must parallel the neutral. You have no choice. Did you guys hear me? No choice. Then the phases have been parallel, meaning you have one set You have to have a neutral with it. Another set have to have a neutral. Okay, so I have no choice really here. So I have to divide. And how many sets? Two to match the phases. So gentlemen, that'll get you 185 amps. Then you take the 185 amps, take it to this table, and that will give you a healthy, you will take two sets, again, two sets of one conductor each. In each set will be one conductor number, 3 odd, E, and a W, and a G, and a T, H, H, N. Slash T, H, H, W. But do you see why we parallel, guys? Because you have no choice. Okay, the last thing, gentlemen, you're going to do is the equipment ground conductor. I'll let you write the stuff. The equipment ground conductor, how do we size the equipment ground conductor? You guys remember how we did it? Based on the overconduction device, 450. So you take your 450 to 250.122 and you'll get yourself how many sets? Two sets of one conductor number 2 A W G T H H N. Everybody knows that we use that table, right? I'm going to size the conduit just because. I'm going to use this calculator, guys, to size the conduit. We'll be sizing it by hand. You guys have been sized conduits. Okay? Now, if you're indoor, what would you use? The cheapest conduit that you can use indoor is called EMT, electrical metallic tubing. It's a thin-walled conduit like this, really nice, thin-walled, easy to install, easy to bend, not with your hand. Hand benders, you know, or machines, but very, very easy to install. No fittings, no threaded. You have couplings on the both sides. That's the conduit of choice for wiring internal with conduit. The conduit of choice. Yes, sir. Yes, they bend this one and they also bend rigid. And a bunch of others. Okay, so if they don't tell you what type of conduit and you're indoor, your conduit of choice is called what? EMT. That's it. The only time you differ from this one is when you go underground. It becomes the conduit of choice becomes what? PVC. Gentlemen, do you know how many wiring methods in the NEC code book? 60 plus. 60 plus. Wire different conduits and cables. You can use the same thing. So for you guys, but what do we typically use, thin or less? Commonly used. Okay, this is the most commonly used one. You're looking at EMT. Conduit, not cables. All right, so let me go size that one for you. I want you guys, I'm going to use it because I'm lazy. I'm going to use my calculator. Here's my calculator, gentlemen. I hope I still have. Here you go. So this is, you can buy it on your iPhone. I don't work. It's an app. Well, you have to pay for it. It's simulator, or you can get it like this.
How much
Okay.
is one? Like 60 bucks.
This is 62 bulk. Okay. Gentlemen, this is how it looks like. So let's go to my calculator. The first thing I'm going to do, just quick, can you guys give me the size? I want you to give me the size of the phase and three-phase, the neutral and the ground, so I can size it. The first thing you need to do, so let's turn off, turn on, and we have, should I make it larger, medium maybe? Okay, is that better? You can see it much better here. Okay, set clear. Can you guys look at this? This is when you hit set clear, it will tell you that this is based on which code? That's exactly what you want. 2014. These guys, when you, every time they have a code cycle, I don't want to work for these guys, but they have a little chip. Can you guys see that little thing here at the bottom? They send you one for $14. And you plug the old one with the new one, and now you're up. Huh? This is not NEC. All the calculation that you need for the NEC is right in this. Most of it. All right, let me size the conduit for you. Here's how you start. First of all, you need to click on conduit. When you click on conduit, the default is what? I just told you. That's the most common, right? All right, this is how you do it. Start with the size. Give me the size of the phases. How many? The phase conductor. What was the size of the phase conductor? Was it 4-aught? Okay, 4-aught. Thank you. I need double. Okay, here's how you do the 4-aught, guys. Look at this. The aught is 0, 0, 0, 0. That's 4-aught. 4-aught is 4 zeros. Okay, now you put the 4 zeros here, but you're going to tell the calculator these 4 zeros are not zeros, they're aughts. So what do? Do you see where it says wire size here? Click on wire size, and it defaults to copper. So 0, 0, 0, 0, 4-aught, copper, wire. Now, next step, it will. Now, how many of these do we have? 3, right? There are 3 phase. So you hit 3 in this order. First, you put the wire, the number 0, 0, 0, 0. Then you hit wire, so it becomes 4-aught. Then the next thing is how many? 3. So you hit 3, gentlemen. And then what insulation? Here's your default, the most common insulation. What was our insulation? THHN. Click on THHN and click again. This is the cross-sectional area of this conductor. That all the conductors. You see, these are all the three of them. The 3 of them together. The cross-sectional area of them is given there. Okay, are we done? No. What else do we have? What was the size of a neutral? Was it number 2? Okay, number 2. Okay, you hit 2 in this order. 2, wire size. Okay, how many of the neutrals do we have, gentlemen? 1. Then you hit 1. And what type of insulation? THHN. You hit THHN. You hit THHN again. It adds the cross-sectional area of the neutral, one neutral, to the 3 phases. Can you see how nice that is? Now we went up. One more, gentlemen. A ground. What was the size of the ground? What was the ground size? Oh, the neutral was 2.
We said they're online.
Oh, you gave me the ground. Okay, that's not a big deal. No, so you gave me the ground first. So we put the ground first, no problem. Now let's go to the neutral. What was the neutral? 3-aught, right? I thought you guys were lying to me, but I couldn't prove it. So 3-aught, here's 1, 2, 3. Wire size. It doesn't matter the order as long as you put the number the same. 0, 0, 0, copper. Now, how many of them do I have? 1. Here's 1. What type of insulation? THHN. Click again. Click again. It adds the ground to the neutral to the 3-phase cross-sectional area. Here's the total cross-sectional area that you need. Okay? You done that. You probably see how hard it is when you do the math by hand. Now, the next step is done. Now look at that. Now hit conduit. Bam! 2.5 inch. No. I set a conduit. Remember, there are 2 sets. We had 5 conductors basically, right? I wish I have a ground here. Here's 4, and then neutral.
Let's use 1 set and 1 conduit.
Yes, a conduit. Can I get you guys when I say a set, meaning a conduit with 4 wires or 5 wires in it, depending on the ground. That's what is set. That's what we want. Now, could you put 2 sets like this in 1 conduit like this? You can't, but right on your piece of paper, you become a fool. Don't want to put 2 sets of feeders in 1 conduit. Pulling them is pain in the butt. One of them burn is another pain in the butt.
Yeah. Quick question now.
Yeah.
Set 2 sets of, and then you parentheses number 1. What does that mean?
2 sets here. This is 1 conductor. This is how you read it. 2 sets means 2 conduits, 1 conductor, number 3-aught, THHN, or 1 conductor, number 2.
I just want to know what the
Yes. The parenthesis is the number.
number of wires.
Yeah, number of wires. Okay. That's it. Now, if you want to change this one into a PVC, look how easy that is. You just keep clicking here. Set. Here's your ENT, electrical non-metallic, another wiring methods. You can't fit it. So you click on another one. Here's FMC 2.5. That's another wiring method. Click on that. Here's intermediate IMC, intermediate metallic conduit. And 2. Look at that, 2 size. Now, if I need to rigid, look at this. Here's my rigid. No, this is not my rigid. Liquid tight flexible non-metallic conduit. All these are wiring methods, guys. This is liquid tight flexible non-metallic conduit, and all these are conduits. Keep going to rigid metal conduits too. Now, if you don't want to keep going like this, they have a shortcut for you. You can, if you want rigid here, what is this? So they will tell you that it comes with this guide, guys. Will tell you if you want somewhere. It tells you If you want rigid head, set this number and then the conduit will give you rigid right away. So there is a shortcut somewhere here. You trust me, it's there. Okay. So that's the size of the conduit. Cool? Now, don't you tell me that you're a fool if you don't, as an electrician, you don't have one of these. Now, when you guys do it by hand, you're going to see how long will it take, pull the information and do the math. Unfortunately, in Minnesota, they wouldn't allow you to use it on the exam, the master exam and journeyman. I've been trying to push it. Oh, if they should, a journeyman or master exam, they should allow you to use that one. If you work for me, I'm an electrical contractor, and you use it, versus go to the NEC code book and find all these numbers and add them by hand. Are you kidding me? We're in the information age, man. Okay, enough preaching. That's it. Give me 5 minutes, guys. I'm gonna switch gear to Revit. That's all. That's all what we did, guys. We sized everything.